Here are some ACS practice problems for General Chemistry 2. We're dealing with equilibrium. The first question is, which is a proper description of chemical equilibrium? A, the frequencies of reactant and of product collisions are identical. B, the concentration of products and reactants are identical. C, the velocities of product and reactant molecules are identical. Or D, reactant molecules react to form products as fast as product molecules are reacting to form reactants. So A, the frequencies of reactant and of product collisions are identical. That's not going to be the answer because the collisions frequency has to be high enough to allow higher than the activation energy to allow the reaction to take place. But they do not have to be identical to be in equilibrium. So that's not it. B, the concentrations of products and reactants are identical. This is not going to be true because the concentrations could be totally different, and the reaction could still be at equilibrium. C, the velocities of product and reactant molecules are identical. This is not true because chemical equilibrium is not related to the velocity. And then D, reactant molecules react to form products as fast as product molecules are reacting to form reactants. This is the answer because chemical equilibrium is when the rate of formation of products equals the rate of formation of reactants. So D is going to be your answer. Question 2. Consider this reaction. What is the correct K sub C expression for this reaction? So first thing we want to do with this kind of problem, we want to look at the states, the physical states that we are given. We see a solid, a gas, and a gas. For K sub C or K sub P expressions, solids and liquids are 1, and therefore they will not show up in your reaction unless it's alone, like right here. But so we can see that this is just not going to show up because we have this gas and this gas. So already, if we can cross out the answers that have 3 terms in them. So right here, no and no. We don't even have to look at what the terms are because we see we're only going to have 2 in our expression. And we can just write the expression ourselves. And it's always going to be concentration of products over the concentration of reactants. That is our formula. So if we look at this, there's a coefficient of 4. And when we write our K sub C expressions, the coefficients are going to become exponents. So let's just write out the concentrations first and not even worry about the numbers. That is our product, and our reactant is Cl2. And that is going to be kind of the basis. But then we look at our coefficients. Coefficient of 4 becomes an exponent. Coefficient of 6 becomes an exponent. So to the 4th power to the 6th power. So this is going to be our K sub C equation. And that matches up here. And our answer will be C. Okay, question 3. Consider this reaction. What is the correct K sub P expression for this reaction? Same exact thing. We're just dealing with pressure instead of concentration. But exact same thing is happening. The only difference is that we are not going to be using these brackets to denote concentration. So let's look at the states first. First thing we do, gas, gas, gas. Okay, so there will be 3 terms in our K sub P expression. So everything has 3 terms, so we can't cross anything out yet. So let's write out our K sub P expression. So it's going to be products over reactants again, but we are going to write it like the pressure. There are 2 products over 1 reactant. The pressure of SO2, so P sub SO2, P sub O2. And then our reactant is P sub SO3. Now let's look at the coefficients. O2 has no coefficient, so no exponent. Ooh, SO2 has a coefficient of 2, so this will be to the power of 2. Easy enough. And then SO3 on the reactant side has a coefficient of 2, and that's going to be to the power of 2 as well. So this is our K sub P expression. The answer choice that matches up with this, well, we do not want these coefficients because these are supposed to be exponents only, so we can just get rid of the ones with those coefficients. Here, these have no exponents at all, so that's flat out wrong. This answer, answer A, matches perfectly with the K sub P expression that we wrote, and that is our correct answer. Question 4, what is the equilibrium expression for this reaction? Okay, so we're still doing the same thing. Look at the states. First thing we do, solid, gas, gas. This is not going to show up. Boom. We can cross out all the answer choices that have 3 terms in it. Wrong, wrong, wrong. Oh my gosh. Oh my gosh. Let's double check it. Let's write it out for practice sake. Concentration of CO2 on the product side, products over reactants. Concentration. Coefficient of 2 becomes exponent over concentration of O2. No exponent because there is no coefficient. This is our K sub C expression. And voila, it's the only one that's left. Easy, easy. Okay. Number 5. Carbon monoxide gas reacts with hydrogen gas at elevated temperatures to form methanol according to this equation. 1.4 moles of CO and 0.3 moles of H2 are allowed to reach equilibrium in a 1-liter container. 0.06 moles of CH3OH are formed. What is the value of K sub C? So now we are going to be solving these beautiful expressions instead of just writing them. So let's start out and let's look what it's asking. It says that these reactants are allowed to reach equilibrium in a 1-liter container. 1 liter is a beautiful, beautiful value to see because it makes our calculations very easily when trying to get to molarity. And at equilibrium, this is at equilibrium, okay? 0.06 moles of CH3OH are formed. So we're going to make a beautiful ice table. Let's get this right here. Beautiful ice table. We're going to write our equation that we are given. Gas. And we see that these are all gas states. So they will all show up in our K sub C expression. So we will have 3 terms. So initial concentration, change in concentration, and our concentration at equilibrium. Let's make a beautiful ice table. Initially, we have 0.4. Well, I like to do ice tables in molarity, but in molarity is, okay, moles over liters. We are given our mole values, and our liter value is 1, so our concentration would just be dividing the moles by 1, which does not change them. So let's put it in moles and it's gonna be concentration anyway. So makes it really simple. So 0.4 molarity for CO initially. H2 is 0.30, and we do not know this initially. We do know it at equilibrium. They give us that here. 0.06 moles. This is, the change is going to be our x values, and since we are forming CH3OH, this will be positive and these will be negative. That's how we know these are being used up and this is being produced. So these are negative. This x value is our coefficient. So we have 1 CO, so that's 1x. Here we have 2 H2s, so that will be 2x. Here we have 1 CH3OH, so that is 1x. And then right here, add these together. 0.4 minus x, 0.30 minus 2x. Oh, and would you look at that? Our x value, because this coefficient is 1, the x value is our value at equilibrium. So this is our x. So now we can solve to find the concentrations of our reactants at equilibrium. So our concentration of CO at equilibrium is 0.40 minus x, which would be 0.06, which equals 0.34 molarity. These are beautiful numbers. So H2, remember, our coefficient must become an exponent, so this is squared. So our value will be 30 minus 2x, and then we're going to square what that is equal to, and we are going to get, let's just, so we get point, there we go, or I guess we don't have a 0. And then our concentration of CH3OH, well, that is what we found, and it's 0.06 molarity. So these are our concentrations at equilibrium, and now we just have to put them in products over reactants like we did in the other ones. And now all we have to do is actually plug in numbers in the calculator and find that value. So we have CH3OH is our product, so 0.06 over 0.34, 0.18 equal, and when we calculate this, we have already used our exponents, that's why I did not. This is not squared, I already squared it. And we get 5.446. If we look at our answers, D is correct. That's exactly what we got. Okay, last question. The graph shows the variation of concentration with time for this reactant at 25 degrees Celsius. What is the value of equilibrium constant for T sub 2? T sub 2 is here. This is the line we are looking at. We don't care about this one. This is quite interesting. I've never done a problem like this before. So we have, look at the physical states. Aqueous, aqueous, aqueous. We will have 3 terms in our equilibrium constant expression. So it's going to be, our expression will be 2, well, it's not going to be 2. It's going to be C squared because our 2 coefficient goes to become an exponent times B. No coefficient, so no exponent to worry about. And then 3A just becomes concentration of A cubed because that 3 becomes our beautiful exponent. This is our value, and we were going to solve for this. What we have to get these values from over here. So B is 2. So we have B times C, which is 4. So that is going to be 4 squared. Why did I write B? Oh my gosh. B is 2. Why did I write B? I'm used to those other questions. A is 3. So that is 3 cubed. And when we put this into the calculator, we get 1.185, which rounds to 1.2, which is our answer for this question. Thank you. Hope this kind of helped. Happy studying.